Today in this video, we will be talking about chain rule to differentiate functions which are not in the standard form. But before that, let me just remind you that this is the sixth video in the series of differentiation. If you have not seen other previous videos, please watch them. Links are available in the description box below. Alright, let's first quickly revise all the basic differentiation rules and standard derivatives, as these will be used frequently throughout calculus. So we have derivative of sum of functions, which is just the sum of individual derivatives. Similarly, the derivative of difference of two functions is just the difference of individual derivatives. Similarly, the derivative of product of two functions is given by the product rule, which is first function derivative of second plus second function derivative of first. When a function is in the rational form, we use quotient rule or division rule. And the rule is denominator into derivative of numerator minus numerator into derivative of denominator whole upon denominator square. Now let's have a look at some of the standard derivatives. Derivative of x raised to the power n is nx raised to the power n minus 1. This is also called power rule. Differentiation of e raised to the power x exponential function, it's same as e raised to the power x. Differential of a raised to the power x is a raised to the power x ln a. Derivative of ln x is 1 upon x. Derivative of trigonometric functions, sin x is cos x is minus sin x. Derivative of tan x is sec square x. Derivative of cot x is minus cos x square x. Similarly, derivative of sec x is sec x tan x, and derivative of cosec x is minus cosec x cot x. Today we will be talking about one of the most important rule of calculus, chain rule. It is applicable whenever you have to find the derivative of a composite function. Now, what is a composite function? The function is written in the mathematical form as f of gx or g of fx, or it can be f of fx or g of gx also possible. Let's see an example. We have a function, for example, sine x square. Now this gx here is x square and f of x is suppose sine x. So if we combine both these functions, then it can be f of gx, because gx is as an input for the fx function. So it is an example of a composite function. So whenever we have these type of functions to differentiate, we always use chain rule. Now, to understand the differentiation using chain rule of composite functions, we need to identify the structure of the composite functions. That is, the outer side and the inner side of the function. For example, if we have a function like y is equal to sine 4x, then we can take this 4x as the inside of the function and this sine x as the outside of the function. And if we need to differentiate in this situation, if we need to differentiate, it will be something like y equal to outside of the function and then a bracket, and then we have inside of the function. Though this way it can be layered as many times as is it possible, but let's assume that there are only two layers at the moment. So we have outside function and the inside function. Now if we differentiate in such case, it will be, first we deal with the outside function. So it will be derivative of the outside part, derivative of the outside function, leaving the inside part as it is. Leaving the inside part as it is means you are not changing that at all. Leaving the inside part as it is. So this is the first thing, and after that the second part is derivative of the inside part. Again, I am assuming that the function has only two layers at the moment. So derivative of the inside part. So we write it this way. So every composite function, whenever we have to differentiate, we have to understand that there will be an outer shell and there will be an inside shell. So when we differentiating that composite function, first we differentiate the outer shell and we leave the inner shell exactly as it is. Into, then we differentiate the inside part. So if we just talk about the same function, for example, sine 4x only, y is equal to sine 4x only. If I just talk about this only, so you can see sine x is the outer part and this 4x is the inner part. So as per this rule that we have just done, dy by dx would be derivative of the outer part. Now outer is sine, the derivative of sine is cos x. Now what is x from here? If you look at it, your x is just 4x. So you leave it as it is. So now the outer part is done, sine x is done. Now you are dealing with the derivative of the inner part, and the derivative of 4x is just 4. That's why the derivative of sine 4x is 4 times cos 4x. Now let's see some of the functions where we need to see whether the chain rule would be applicable or not. So you see 2x minus 7, a plain linear function. So no, the chain rule is not required here. Similarly, if I say y is equal to x cube, exactly like the standard format, so chain rule is not required here. Similarly, say y is equal to sine of x, exactly a standard format. So chain rule again not required. But if I have something like y is equal to sine 2x minus 7, now this is not a standard function. So yes, chain rule is required here. If we have y is equal to sine and something like x cube, so sine x, had it been a standard one, it should be sine x, but it is sine x cube, not in the standard format. So yes, we need the chain rule here. And if I write it like y is equal to 2x minus 7 cube, for example, again not in the standard x cube format. In place of x we have another linear expression as 2x minus 7. So yes, we need the chain rule to differentiate this function. Also we need the chain rule. So this is the basic idea. This is the basic knowledge about the chain rule. Now let's see some questions and understand how we do these kind of differentiation of these composite functions. So if I have a function like y is equal to sine x square, so obviously not a standard function. Why? Because a standard function would be y is equal to sine x, and if I have to differentiate, y prime will be just cos x. That's the derivative of that, so it is just cos x. But in my case it is not the x, not in the standard format. So how will I go? It is dy by dx. I will say derivative of the outer shell. So it is derivative of the outer part multiplied by derivative of the inner part. The only thing you need to understand here, when you are talking about the outer part, you are leaving the inner part as it is. That's the rule which we discussed there, as it is. So I'm just writing it once. Now we will completely keep using it now onwards. So derivative of the outer part, leaving the inner part as it is, and this is the second one. So if I differentiate it, this is sine x square. Obviously outer part is sine, so its derivative has to be cos, but we have to leave the inner part as it is, so it is cos x square times derivative of the inner part is x square, so obviously the derivative is 2x. So the derivative of y equal to sine x square is simple cos x square times 2x. Let's take one more question. Suppose y is equal to cos e raised to the power x. Now again, if I have to find the derivative, the outer part derivative would be minus sine x. So I'm writing minus sine, leaving the inner part as it is, so e raised to the power x. Now the outer part cos done, so now the derivative of inner part, which is e raised to the power x, so it has to be just e raised to the power x. Now another question. Let's say it is y is equal to sine of cos of x square. So there are three layers in this question now. But the derivative, the process would be very simple, because we know that start from the outer one. When I'm starting with the outer one, leaving the inner part just as it is. So it is sine x for me. So obviously the cos answer would be cos, and inner part would be just as it is, cos x square. Now I have solved the sine. So I have solved the completely outer part sine I have solved. I'm left with cos x square. So derivative of cos x square is definitely minus sine x square, because the derivative of cos is minus sine. So minus sine, and leaving the inner part x square as it is, so it is x square, and that's it. Now the second part is also done, second cos is also done. I'm left with the innermost layer now, which is x square. So the derivative of x square, or derivative of the last inner part now, is just 2x. So the full answer would be something like this. It is minus 2 times cos x square, and after that sine x square is the final answer. Let's take one more question. Y is equal to cos of ln x. Two layers, but not in the standard format. So obviously we will use the same method. So dy by dx, first the derivative of the outer layer, derivative of cos, which is minus sine, leaving the inner layer as it is. So answer would be minus sine, leaving the part as it is. So it is minus ln x into, I have solved the outer cos. Now I'm just solving the inner part ln x. So the derivative of ln x is just 1 upon x, and that's the answer. All right, let's take one more example, which is y is equal to ln square. Then we have 10 cube, and then we have x raised to the power 4. So first, write it in a proper format. So I'm writing it ln, then I have 10 cube x4, and then I have square. This ln square can be written as ln and then the whole square, like that. So when I am differentiating, first it is the differentiation of the most outer part, which is like x square for me, power rule. So the derivative of x square is just 2x. So the derivative of the outer part is 2x. X is the inner part, so just leaving the inner part as it is, ln 10 cube x raised to the power 4. So it is like this. Now that's the derivative of the most outer part, and after that I will say derivative of the inner part now left, which is ln of 10 cube, and now we have x4. So in a way, if I say this is the next innermost layer, then I have ln and this much. Now solving this 2 times, it is exactly the same way, ln 10 cube x4, and now derivative of this. Now the outer is ln, so the derivative must be 1 upon x, because ln x is 1 upon x. So it is 1 upon x, which is 10 cube x4, and now derivative of the inner part. So obviously it is d by dx of 10 cube x4. So this 10 cube x4 can also be written as 10x4 and then the whole cube from the outside, like that. Now if I just combine everything together, it is 2 times ln 10 cube x4 as it is, divided by 10 cube x4 into derivative of 10x cube, and the power is 3. So the outer function is x cube. So the derivative should be 3x square, which means 3 10 x raised to the power 4 and then square, because x cube is 3x square. So this is done. Now it further goes as derivative of 10x4. So derivative of 10x4, if I write the entire thing once again, it is 2 times ln 10 cube x4 divided by 10 cube x4 times 3 10x4 and then whole square as it is. This will remain as it is because we have to differentiate this part. Now this is 10x4, first the outer part. From, if you look at from the outer side, it looks like 10x function. The derivative of 10x is sec square x. So its derivative should be sec square x. X is x4. So we have solved the outer part, which is sec square x4. Now if I remove this 10, if I remove this outer part, I am just left with the x4, and the derivative would be just 4x cube, because the derivative of x4 is 4x cube. Now let's combine all the terms together. 4 into 3 into 2, that should be 24. Then this cannot be, this ln 10x cube will remain as it is, ln 10 cube x4 will remain as it is, and then in the denominator I have 10 cube x4. So here I have 10 x4 square, so it can be written as 10 square x4 also. And if I look in the denominator, I still have 10 cube here, 10 cube x4. So everything is same, it is power 2, it is power 3. And over here we have sec square x4, which can be written as 1 upon cos square x4. So it is 1 upon cos square x4 times x cube, which will remain still like this. So you can notice now 10 square from the numerator and 10 cube from the denominator, this will cancel. I am still left with 1 in this case. Now let's just quickly finish the question here. So it is like 24 ln 10 cube x4 divided by, I'm left with, here I'm left with 10x4, 1 10x4, so I can write it as sine x4 here. This 10x4 can be written as sine x4 upon cos x4. So that cos x4 goes up, and I have in the denominator cos square x4. So this is cos square x4, and in the numerator we still have x cube here. So we still have x cube here. Now you can see this cos x4 can also be used. This cos x4 and this 1 cos x4 is cancelled. So ultimately now we are left with over here 24, this is 24 x cube, then we have ln, we have 10 cube x4, and the whole thing is then divided by sine x4 times cos x4, right? So this is the final answer, which in the most simplified form. So ln, and it is exactly goes like this. So idea is very simple. There may be multiple layers. You start from the outermost layer, solve that, go to the next inner layer, solve that, and go to the innermost layer and keep differentiating like that. Alright, now let's try to solve one more question using the chain rule. It is y is equal to e raised to the power under root of sine of ln x square plus 1 whole cube. So here we will follow the chain rule, and I will try to write the answer directly now, following the same method, the derivative of the outer part and then into derivative of the inner part. So it is like right now it is like e raised to the power x type. So we know that e raised to the power x derivative is always remain same as e raised to the power x. So it is still e raised to the power sine, then we have ln, and then we have x square plus 1 cube. So now e raised to the power x derivative is e raised to the power x. So we have solved e. Now we have to solve derivative of under root of this. So if you compare it with the standard function, it is like root of x, and derivative of root of x is always 1 upon 2 root x. So it is 2 under root x, which is sine of ln of x square plus 1 cube. Now we have solved the under root also. Now we have to solve the derivative of sine ln x square plus 1 cube. So if you look from the sine, outer sides is sine, so derivative of sine x would be cos x. So obviously it should be cos of, leaving the inner thing as it is, so ln x square plus 1 whole cube. So sine is also solved. Derivative of sine x is cos x. Now when sine is gone, you are left with ln of x square plus 1 raised to the power 3. Ln of x square plus 1 raised to the power 3. Now understand, ln of m raised to the power n, it is similar to ln of m raised to the power n, and the logarithmic rule will work here. 3 will come in front, and now we are left with ln of x square plus 1, and I know the derivative of ln of x square plus 1 is actually 1 upon x square plus 1. So ln also gone. Now I am left with only x square plus 1, and the derivative of only x square plus 1 is just 2x. So we can combine all these terms together to get our final answer, and as such nothing will be cancelled here, so we can just leave it this way also. Normally in the exam they give a proper format where you are supposed to leave your question. Normally they say prove that dy by dx equal to this much. So in that case, you can rearrange your terms to get that form, right? So that was again a question solving the using the chain rule method. So that's all for today. The next video will be on implicit functions, derivative of the implicit functions. Okay. Well, if you could understand what I was trying to explain, please like and subscribe to my channel. And if you want to be notified for my next video, please press the bell icon also. Thank you.